Welcome to part 2 of GGplot series. Today we're focusing on aesthetics, how to make geoms much more exciting and interesting to look at. We're going to look at sizes, we're going to look at shapes, we're going to look at transparency in order to make your graphs much more compelling. Why should you trust me? My name is Bogdan Popescu, and I'm an assistant professor at John Cabot University of Rome. I also used to teach at Oxford and at Princeton. In my experience, I've taught many undergraduate and graduate students both statistics and the power of data visualizations. So let's dig right in. Okay, this is the second lecture in the series on data visualization. So we're talking today about designing with aesthetics in ggplot, how to use color, size, shape, transparency, and line type. So we will be able to identify and apply key aesthetics in ggplot. So when to use those elements that I just mentioned, we're going to distinguish between mapping versus setting aesthetics. We're going to look at how to enhance plots by layering aesthetics onto common geoms. And then we're going to evaluate when aesthetics improve clarity versus when they create clutter. So remember this graph that shows how layers are added on top of each other in ggplot. We start off with data, we then move on to geometries, aesthetics, and then the other things are optional, things like facets, coordinates, annotations, and themes. But this is how aesthetics, we're interested today in the aesthetics layer. So we learned so far that geoms are really the shapes that our data takes on a graph. Aesthetics are the kinds of things that bring a graph to life. These are things like color, like size, shape, transparency. So AES, the aesthetic are the kinds of things, or is the kind of option in ggplot that allows us to map these aesthetics and to link the data to specific visual features. So aesthetics, more conceptually or more generally, are things that allow us to highlight comparisons and to guide the viewer's attention. So previously, we looked at all these different types of simple geoms, things like points, columns, bars, text, and line. So once again, you might remember that geom points are it's a type of geometry that allows us to examine the relationship between two variables. Geom column is something that allows us to examine totals or percent by category. Geom bar does the same thing, but in the geom bar context, we only supply X. We don't need to supply Y. Geom text allows us to annotate data, and then geom line allows us to examine again the relationship between variables. So these are the kinds of aesthetics that we could possibly have for points. I would say that points is the type of geom with the most aesthetic options. So here they are. We can have different colors for discrete values. So these are things like color choices. We have different colors, yellow, green for our respondents. We can have color for continuous variables. We can also have both discrete and continuous, so we can represent points in different sizes depending on discrete or continuous values. We can have fill, so this essentially means that we can control the color inside our points, and then we can have a black contour. We can also have discrete variables represented in different shapes. And then finally, we can also represent our data, either discrete data or continuous data, using different levels of transparency or alpha. So just to recap, we can have different colors when we want to differentiate between different categories. We can have continuous colors when we want to show gradual change in a continuous variable. We can have different sizes for different discrete or continuous variables. We can have different fills, so a different fill color for both discrete and continuous variables. We can have different shapes, that allow us to distinguish between different categories in our data. And then alpha, once again, both for continuous and discrete variables if we want to map categories or quantities over transparency. So let us look at some specific example. This is one situation where we use points. So imagine that we have 9 countries that have their level of democracy from -10 to 10, and their GDP per capita measured in thousands of dollars. This is once again what our data looks like. EG1, we have 2 columns, democracy and GDP. And once again, democracy ranges from -10 all the way to +10, where -10 means less democratic and 10 means highly democratic. Excuse me. GDP also ranges from 2, which is a low value for GDP, all the way to 27, a much higher value for GDP. This is what our data looks like. We have 2 columns, democracy and GDP. And this is how we represented our data before. On the x-axis, we have the level of democracy. On the y-axis, we have GDP per capita. The points in this graph represent the countries. So just to remind you, we have ggplot, we have the data, EG1, we have the x variable, which is the level of democracy, and we have the y variable, which is GDP per capita. Okay, this is how we can use discrete. So we have the same situation, but let's imagine now that we have more variables. It's worth paying a bit of attention here because we're going to use this example in many other situations. So we still have EG1. So these are the 2 things that we had before, democracy and GDP. Let us now imagine that we have a few additional variables. One is the country. So this is essentially the country name. All these points we want to have a name associated with them. So we have all these 9 countries. Then we have another variable called region. So what continent they're part of. We have another variable called population in millions. We have another variable called income. So if countries that are part of low income groups, middle income groups, and high income groups. This is a bit trickier because this is a factor variable that I'm going to show you in a few slides how this affects our interpretation and what this really means when it comes to mapping aesthetics. And then we have a final variable that captures corruption. So levels of corruption in all these 9 countries. So once again, unlike what we just had before, where we had only 2 variables, democracy and GDP, we now have all these additional variables: country, region, population, income group, and corruption. So let us say, so this is what our new data set looks like: country, democracy, GDP, region, population, income group, corruption. And this is how we can use our first aesthetic, which is color for discrete variables. So instead of just having black and white points, now we actually have them colored. So if you look at the legend, you can see the variable that we decided to map. This is the variable called region. If you remember, these are the continents that these countries pertain to. So this is how we produce this graph. We have EG1 as the data. We still have the X, which is equal to democracy. The Y equals to GDP. And finally, something new, we have here color equals region. So this is the thing that allows us to map the different regions with different colors. So instead of just, once again, having a black and white dots, now we have discrete variables or discrete values pertaining to the region variable represented with different colors. This is, for example, how we can represent continuous variables. So notice, if you look at the legend, now we're trying to represent corruption with different shaded colors. So corruption, as you might remember from the data construction, is a continuous variable. So countries have corruption levels seemingly from around 20 all the way to 80. So this is how we create this gradient depiction. Once again, we start off with data EG1. We have an X variable, which is democracy. We have a Y variable, which is GDP. And then we color corruption. So it's very similar to before, but rather than having a discrete variable, before, remember, we had region. Now we have a continuous variable. We have numbers from 20 to 80, which is why this allows us to represent points with gradient colors, gradient blue. Okay, let us now examine size and how to use the size as an aesthetic option for discrete variables. So remember that we also have this variable called income group. What kind of income group these countries pertain to? So you can have low income group, so this is the small point. You can have middle income group, which is the medium-sized circle. And then you can have high income group, which is this large circle. So how do we represent this in code? You still have EG1, you have X democracy, Y GDP. Now we have this option here, size equals income group. So this is what allows us to represent discrete variables for mapped onto the size aesthetic. We can also represent continuous variables using size. So in this particular situation, so here we had income, here we have population. So this starts from 25 all the way to 100. So this is how we represent it as before, X and Y, GDP and democracy respectively. And then we say size equal population. Remember, this is in millions of inhabitants. So notice how we can represent, you can use size both for discrete variables, but also for continuous variables. Moving on to fill discrete. So this is very similar to color, but the difference here is the fact that we have the black contour and we simply color the inside of the circle. So here we decided to go for income group. Let us now examine how to represent this. So we have the data set, which is EG2. We have X, which is democracy, Y, which is GDP. And then we use fill. We're trying to fill different income groups. However, there is one point to be mentioned here. The fact that this option, fill, only works for specific shapes. So we're going to look at shapes in a few slides. But in order to have in order to have circles, in order to have dots colored, we need to specify this thing here, shape equals 21. This could also work for 22, 23, 24, 25, but it is important to have 21. If you're not using shape equals 21 or one of those numbers, you will not be able to color points. You will just get black points. And then here you specify the contour. I decided to obviously go for black, but obviously you can try other colors as well. So that's the takeaway here. It's important to specify the shape, and it has to be between 21 and 25. And then this is going to produce a graph that looks like this. So this is another example for discrete variable. Okay, this is, for example, how to use fill continuous. So this is, again, very similar to using color, but for a continuous variable. So here we're using fill equals corruption. We're still using the same shape, 21, and we are representing contour in black. So let us look at the final output. You notice here these gradient changes in blue, and then you do see the black contours. So this allows us to see corruption for all these countries. Okay, this is how we use shape, right? So instead of representing maybe colors for different continents, maybe we want to represent countries with using different symbols. So have a look at the graph that you have Africa, Americas, Asia, Europe. So let us have a look at the code. Now we have this alternative option here in aesthetic, which is shape equals region, and then geom point. So this allows us to differentiate among different categories using different symbols. Okay, alpha. As you can see in this graph, alpha is the option that has to do with transparency. We can map our values pertaining to different variables using different levels of transparency. So in this case, as you can tell based on the legend, we are using the region variable, and we want to represent countries with or the region of the country based on different levels of transparency. So the light gray here, it's the highest level of transparency. Europe is the lowest level of transparency. You cannot fully tell based on this graph because the graph already has a gray background, but maybe you can see that the gray here is much less transparent compared to the gray here. So here's how we represent this in code. Alpha equals region. It's just as simple as this. This allows us once again to represent the region that these countries belong to based on different levels of transparency. This is how we represent continuous variables, so similar to before, but instead of having region, now we have corruption. So remember, corruption is a continuous variable ranging from something like 20 all the way to 80. So you can see that countries that have lower levels of corruption are represented in more transparent black, whereas countries that have a high level of corruption, they are represented in a black that's opaque or in a black that has very little level of transparency. So notice once again how both continuous and discrete variables can be represented using different levels of transparency. Okay, as you might imagine, you could in fact use different levels. You can use multiple aesthetics in order to represent different aspects related to your data. So here's a readable version of how to use multiple aesthetics to depict different features about the data. I'm saying readable because I'm going to also give you an example of unreadable. So here I want to represent both region and population. So I would like to represent region with different colors, and I would also like to represent population pertaining to these countries using sizes. So here's how we do that. We still have X and Y as before. The difference is that we finally move the aesthetics under geom point. So how do we do that? We use color equals region and then size equal population, right? So this is how we map region onto color and how we map population onto size. So this allows us to get a graph that looks like this. Okay, I mentioned readable. Here's an example of an unreadable graph. So technically this is correct. We're representing corruption using different levels of transparency. We're representing a region using different colors. We're representing income group using I'm going to have to look exactly how this is depicted here. And we're also using population using different circle sizes. This is unreadable. There's way too many distinct aesthetics that make it almost impossible for someone to be able to make any meaningful conclusions based on this graph. So this is how we do this. Right, so income group is really represent different fill colors, but it's useless because we already have specific shapes as we discussed earlier. So if we go for this kind of graph, it's too much. There's no way to represent so many features or so many features corresponding to the data. It's just impossible for a viewer to understand what this graph is about. If all these features are somehow important, it's probably a good idea to create a separate graph. So have 2 graphs or 3 graphs that are separate that kind of focus on a specific feature of the data rather than trying to put all these different features together in the same graph. Okay, Mapping versus a setting. So these are very typical mistakes that beginners make when it comes to ggplot. So mapping is this idea that the aesthetic varies with the data. So this is something that we put inside this AES function. Setting is really this thing when the aesthetic is fixed. So this is when we put the option outside of the AES. So imagine that we have this type of data, EG2, where X has values from 1 to 5, and then Y has values from 2 to 10. And then we have all these different groups, A, B, A, B, A. This is what our data looks like. And then this is the difference, for example. So this is where mapping is put inside the aesthetic. Notice how we put group inside of color. And this is when we put color outside of the aesthetic, right? So let us have another look. Color here is for groups. So remember our groups are A, B. So this is going to result in turquoise and pink colors, whereas this other one only results in red. All our dots are in color. So hopefully now you see the difference between putting the mapping inside aesthetic. So here it is, AES, and the aesthetic, and then putting it outside. So notice that we do not have AES here. Okay. It's a common mistake to do this, so you have to be aware of it, right? So if you put the aesthetic here, if you write color equals red, this is going to result in the feature being mapped out in the legend. If you put it outside, then obviously this is not going to be mapped out in the legend. So the left plot is wrong because red is treated as a category. So ggplot uses this as a legend. The right plot, the red is just a style, right? So this is going to be all of these features that will be depicted in red. So this is a common mistake that many people do, many people make when they start with their journey with ggplot. Putting this here in the aesthetic, which results in this legend, which is useless. Obviously, the better version is to have color equals red, which applies the style to all the points in the graph. Okay, moving on to column aesthetics. So what we have covered so far are types of aesthetics that apply to points. We can also have aesthetics that apply to columns. So here's all the different kinds of aesthetics that could apply to columns. You can have colors applied to discrete variables, to continuous variables. You can have different fills. You can have fill and color. We can have fill continuous, and you can also have alpha. So the color for columns allows us to differentiate categories with distinct outlines, although these are rarely used, as I referenced here. But in addition, when was the last time that you saw columns that look like this? So this is rarely used. The same thing goes for representing bars or representing columns in different colors. Fill, this is definitely very common, right? So to represent columns using different colors, the same with fill and color. So this means that you're combining an interior color fill with a contrasting border, typically black. Continuous fill, that's also slightly rare. And then the same thing with transparency. So it's technically possible, but thinking about what kind of graphs many scholars use, I would say that it's mostly fill and color. So let us look what that would look like in our case. Remember that we have a survey with the level of education for different people, and we have all these different items. This is what our data looks like. So one single variable, education. Remember that if we want to use column, we have to first count these different values. So we would do this using this dplyr function, which allows us to get a new data frame that has two columns. One is education, and the other one is how many entries or how many observations we have for all these different education levels. So this is what we had before, the boring black and white or gray plot. So remember how we produce this. So we have the data frame, we have the X, and we have the Y. So this allows us to see how many respondents we have for each individual educational category. And this is what our data looks like if we decide to fill these categories with different colors. So already much more lively, so to speak. So let us look how we produce that. So we have the data frame, we have the X, we have the Y, and we have the fill, right? So remember that we have these three educational categories. This is what allows us to color our bars using different colors. Okay, this is how we use discrete, how we fill our discrete variables, but we also use contour. So similar to before, we have fill, but we have color black. So we want to depict, we somehow want to contour our columns. Line width is also the option that allows us to decide how thick the contour should be. So these are very typical ways to use fill with either with a contour or without. Okay, line aesthetics. So these are the different line aesthetics that you could conceptually have or technically have, but here too, some are more rare than others. So let us look at the different choices. So color discrete, when you're representing lines like this, so this means that you want to distinguish groups with different line colors. Color continuous, you can show gradient for lines, but as you might imagine, that's very rare. You can also use line width for both discrete and continuous variables, but I would say both of them are rarely used. This is a very common aesthetic for lines, this thing here. So to represent categories using different line types. So this means that sometimes you may have dashed lines, sometimes you may have continuous lines. If you want to identify specific features pertaining to the data, and I'm going to show you a very good example where this applies. And then the same with alpha. It's technically possible. So alpha, remember, is the thing that allows us to depict our observations with different levels of transparency. But in practice, this is not used. So let us look at some example. And this is a new example. Suppose that we have data on average voter turnout in national elections over several years, and we're interested in seeing participation trends. So imagine that we have this EG4 variable where we have year from 2000 to 2020, and then we have turnout in percentages. This is what our data looks like. This is what we had before, right? It's a simple time trend that looks like this. So we have the data set, we have the X, we have the Y, and we have a geom line. This is the most simple time trend that you can think of. Let us now imagine, let us make our data set a bit more complicated. Let us imagine that we not only have the years, but let's imagine we now have data on turnout for two countries. Let's imagine we have turnout in the US, and let's imagine we have turnout in the UK. So we have 6 observations for the US and 6 observations for the UK. So simply copy and paste this code in order to produce a toy data set. This is what our data set looks like. So we have 3 variables, year, turnout, and country. So this is how we can represent distinct categories using different colors. So this graph shows the evolution of turnout for the United Kingdom and the United States. This is how we represent these colors. We simply add the color option within aesthetic. So we put this here, and this allows us to produce a graph like this. This is very commonly used when you want to show different categories for your time trends. You want to show how voter turnouts evolves for different countries. So this is a very common use. Another use for lines is line width. So you have, for example, a situation like this where the United Kingdom has a very thin line, and then you have the United States that has a much thicker line. So the way in order to obtain this effect, you simply add the line width option within aesthetic. So you put here line width equal country, which will allow you to create a graph that looks like this. The more common version of this is to represent different lines with different line types. So it's much more common to have, for example, dotted lines. So here's how we represent this. Line type equals country. So this allows us to represent different categories within our data set with different line types. As you might imagine, you can also combine different features. So here's an example in which we use both line type and color to represent the two distinct features of our data. This is how we do this. We have the X and Y, and then comma, line type, and color, country. Notice that we have the same category depicted or used in both of these aesthetics. This is what allows us to have this represented in the legend as one item. Otherwise, you could have more than these two items in the legend. And then it's also fairly common to use points alongside geom lines. And the reason for this is because you can more vividly see where the observation lies. So you might be tempted to think that there might be observations here too between, for example, 2009 or in 2011, where in fact there aren't any. The only observations are exactly where those points are. So if we want to use points alongside lines, we simply do this. Geom point at the end of our graph. Okay, moving on to complex geom aesthetics. So you might remember from the first lecture that we also covered a variety of complex geoms. I'm not going to cover all of them because all of them have different types of aesthetics. For example, box plot, the useful aesthetics typically are fill and color, and it's advisable to avoid size and shape. Histograms have fill and alpha, and it's obviously advisable to avoid shape. Density has color and line type. Violin has fill and color. Smooth has color and line type. And then SF have fill and color. Okay, so let us look at an example of a complex geom. So geom box plot. So once again, let's remember an example that we used previously. Let's imagine that we survey a group of people, men and women, about their trust in government. So we would like to know what the common or compared typical values and how spread out the answers are for men and women. Once again, this is our data set, EG6. We have men and women, and we have 20 observations for each. This is, for example, what our data looks like. Let us depict once again the distributions for the two categories using box plots. Just to quickly recap, this is how we produce this. We have X equals gender and Y equals trust, and then we have box plot. Excuse me. So this is how we represent these ones, the same boxes, the same categories, using different colors. If you ask me, it's unnecessary because you already have these two categories on the x-axis, but you could have conceivably some situations in which you would like to also use colors for different categories. So how do we do this? Literally add fill within the aesthetic. Add fill and then the category that you want to use for fill. In the end, the effect is the same, but we have also an additional aesthetic dimension, which is color. Fill and alpha could potentially be used for histograms. So it could be useful if you want to depict different dimensions of the data. So this is a histogram that shows the distribution of values for men and women. So how do we do this? We have fill. Remember that fill is the thing that's responsible for colors here. And then I'm also using, so these are options that we had before. The new additional elements that I'm using that are necessary are alpha, which is the thing that's responsible for transparency, and then position equals identity, which is just an option that needs to be added in order for this to work in this manner. So why this is helpful is because this allows us to see the distribution of values of trust for the two genders. Okay, another example of use of color is for geoms. Remember, geoms is the thing that we can use in order to make maps. For example, this is the very typical map, which is called a choropleth map, which shows intensity of a specific variable. So in this case, this map shows how many people live in all these different countries. This is the log of that variable. So this is what this looks like. Once again, these are packages that you need to have on your machine and steps that you need to do in order to extract the shapefile, the data. Remember that we did this before, so these are the points, the maximum, the extremes of the extent of Europe. And then how we create that choropleth map, we take the ggplot, we then use geoms, and then within the aesthetic, we use fill in order to map a specific variable onto the map. So in this case, we're looking at population, written as pop underscore est. So this is like estimated population. And then we also take the logarithm. And the reason for this is that given the data set that we have, this allows us to better see contrast and differences between countries. And the reason for this is because we zoom in to Europe. If we were looking at the entire world, then we would be able to see contrast more effectively. If we weren't using the log and we still focused on Europe, we would not be able to see differences among countries. So I encourage you to actually drop the log and see what the effect is. But I also encourage you to just get rid of the extent and see what the world population looks like in different countries. So this is how we obtain choropleth map, a map that allows us to show how a variable varies across a geographic space. Okay, moving on to color and accessibility. On the most fundamental level, we need to use the right colors for our visualization. So this is important because we want to be clear and readable. We want to make sure that our graphs are accessible. For example, they're friendly for colorblind people. We also want to make sure that we emphasize different dimensions of our graphs using the right tools. And then we want to be consistent. We want to make sure that we use a consistent color palette for the same project. So when it comes to colors, it's important to note that about 8% of men and 0.5% of women have some sort of color blindness. So this means that the typical colors that ggplot provides to us are not necessarily the most colorblind friendly colors. The response in ggplot is Viridis. There's a Viridis palette that allows R to produce visualizations that are easily read by people who are colorblind. So these are kinds of palettes that are not colorblind friendly and that are frequently used by ggplot. These are the non-colorblind friendly colors that we have been using so far. And these are the Viridis schemes. So these are the type of schemes that are helpful and easily accessible by colorblind people. So let us examine how using the Viridis scheme changes the appearance of our graphs. So once again, this is the data set that we have. This is EG1. So these are countries, the 9 countries that record their level of democracy and their level of GDP. But imagine that we also have these additional variables in our data. So the country that the countries that we're dealing with, the region. So what continents are these countries in? their population, their income group, and their level of corruption. Yeah, so remember, this is an old data set. This is what it looks like, all these different columns. This is the old non-Viridis color scheme. So remember that in this context, we're trying to simply depict different countries with different colors. We wanted to illustrate what continent they're from. And this is what happens if we're using the Viridis color scheme, right? You can already tell, hopefully, that this is much more helpful than this. So let us look and investigate what this looks like in terms of code. So we still have color equals region, but then we do have this additional option here, which is scale color viridis D, right? So this is what allows us to use the viridis color scheme. I actually encourage you to also try Magma, Inferno, Cividis to see how the different color scheme impact the way the final product looks like, or the way the final product looks. Okay, this is what we had before for continuous variables. Remember that we're trying to show the level of corruption for different countries. This is what it looks like if we're using the Viridis scheme. So notice already, this is so much better. Like you can, even if you're if you're not a colorblind person, you can clearly see this difference much more effectively. So this is how we represent this. We have X, Y color, and then we use the scale color underscore C viridis. So this allows us to use the viridis scheme for all these different colors. So I would also like to draw your attention to the following. Scale color viridis C, the C thing stands for continuous, as opposed to D, which stands for discrete. So even this option helps us tell to tell what kind of variable we are dealing with, either discrete or continuous. Okay, the most effective way, or one of the best usages for Viridis is when it comes to representing data on the map. So this is our choropleth map when we're not using Viridis scheme. Remember that we're trying to map out estimated population. So once again, this is what the geoms function does and how it's represented. This is what our data looks like if we're using the Viridis color scheme. So how do we do this? We simply use the C at the end, scale fill viridis underscore C. Notice the underscore C, which stands for continuous. You already can tell that this is a superior version of the map. Okay, what have we learned? In the past lecture, we looked at simple and complex geoms that provide the structure. This session, we focused on aesthetics. So aesthetics are the kind of thing that provide meaning to our graphs. So we can use things like color, size, shape, transparency, line type in order to highlight different patterns in our graphics. It's important to distinguish between mapping versus setting. Aesthetics can be used to clarify content, but it can also confuse if they're used too much or if they're used when it's unnecessary to do. So the takeaway here is that it's important to create plots that are clear, that are engaging, and that are persuasive. Thank you, and see you very soon. I hope you enjoyed this video. If you found it useful, please don't forget to subscribe, give this video a thumbs up, and please comment down below if there's something in particular in relation to R or to ggplot that you'd like me to make a video about. Thank you, and see you soon.